everyone. So today we will continue with the chapter Laws of Motion. Sir Isaac Newton gave 3 laws of motion. So what does the first law states? Newton's first law of motion. Newton's first law of motion. It states that a body continues to be at rest or continues to be in uniform motion until and unless an external force acts on it. What the Newton's first law of motion states? It states that a body continues to be at rest or continues to be in uniform motion. Uniform motion means uniform velocity until and unless an external force acts on it. So here the external force is acted on an object either to move a stationary object, to bring the stationary object in motion, or to stop a body which is in motion. So in both the cases we need an external force. Now we can say that force is the change in force brings the change in velocity. Force brings the change in velocity. Okay. If there is change in velocity, what is the definition of acceleration? Acceleration is the rate of change of velocity. So we can write force is the change in acceleration. Is also a change in acceleration. Two things will happen here. When there is change in acceleration, force brings a change in velocity, and because of force there is a cause of acceleration. Here the direction of motion if the direction of motion is like this, then acceleration will be positive. Okay? When an external force, suppose a body is at rest, you are applying a force. What will happen? The direction of motion will, if the direction of motion is along to the direction of force, we get acceleration as positive. If the frictional force is acting, so frictional force will be opposite in direction. So frictional force will be acting this way. To stop the force, any external force is applied to stop a moving object In that case, acceleration will be equal to negative. That is, retardation will be there. We can say force can bring change in velocity, force can bring change in acceleration. When we are saying force is bringing change in velocity, means there is a change in speed or in direction. When we are saying force brings the change in velocity, means maybe speed is changing, or maybe direction is changing, or maybe speed and direction both are changing. Like we can take an example of football. When players are playing football, teams will be there. One person will take the ball and he will try to put the ball in the goal post. So what he will do, either he will change the direction or he will change the speed, or he will change both the speed and the direction. So force can cause the change in velocity, force can cause the change in acceleration. Next thing, force can change the shape. Force can change the shape. What is the meaning of this? Can you give any example? Okay. Take a rubber band. Okay. Stretch the rubber band. The rubber band is a solid. Okay. When you are stretching it, what will happen? The shape of the rubber band is changed. When you are applying force in a rubber band and you are stretching it, the shape of the rubber band will change. So we can say that force can also change the shape. Okay. Now, few questions. While traveling in a bus, when you are not holding any support, while traveling in a bus, when you are not holding any support, you tend to fall backward when the bus starts suddenly. Okay, got my question? Similarly, you tend to fall forward when the moving bus stops suddenly. Next question, what happens, like why is it that when the bus when a bus is negotiating in a high speed, in a full speed, and takes a sharp right turn, what will happen? You fall to your left side. Vice versa, when the bus is taking a sharp left turn, then you fall on your right. Why all these things are happening? Just to find the answer, we'll go to Newton's first law of motion. What the Newton's first law of motion states? It states that a body continues to be at rest and continues to be in uniform motion unless and until an unbalanced force, either we can call it external force or unbalanced force, acts on it. Okay, so the tendency of an object to be at rest or in uniform motion this tendency is called inertia. is called inertia. This is a new term for you children. The tendency of an object to be at rest or in uniform motion, just a minute, in uniform motion unless an unbalanced force acts on it is called inertia. Is called inertia. This tendency is called inertia. Means if a body is at rest, suppose for example, same example like when you put a ball on the table, okay, and if the ball is on the table, it will not start moving on its own, okay. For days together, months together, years together, ball will remain at that place unless and until you will apply some force to keep the ball in motion. Similarly, if we will take a frictionless surface and we will keep a ball moving, then what will happen? The ball will not stop unless and until some external force will act on it from in the opposite direction. Okay. So, can you give some more examples? Let's take the example of a carpet in your house. If we will take a very dusty and very dirty carpet and then we want to clean it, what your mother will do? She will keep the carpet and she will take one stick and she will apply large amount of force and she will start beating the carpet. In the carpet will come in motion, but the dust particles in the carpet is at rest. They will want to remain at rest only, but when the carpet is in motion, the dust particles will fall down. So this is the why this is happening? This is happening because of inertia at rest. Okay, now before that let me tell you one thing. So now we have understood what is inertia. The tendency of an object to be at rest or in uniform motion unless an unbalanced force act on it. If there is a balanced force, we have already read about balanced and unbalanced force. When a balanced force is applied on any object, there will be no motion, there will be no change in the motion. Okay? The body will be at rest. But if unbalanced force is applied on any object, the object will come in motion. So now we will see different types of inertia. Now we will see different types of inertia. What are the different kinds of inertia? First is inertia at rest. Next is inertia of rest, inertia of direction, and next is inertia of motion. Okay. Before going to this topic, let's see one example. This is a big box of suppose 10 kg. Okay. Suppose 100 kg. And this is a small box of 10 kg. Okay. This is a big box, maybe some stuffs are there inside this box and it weighs 100 kg, and this is a small box which weighs 10 kg. You are applying same amount of force here. What will happen? This 10 kg box will start moving, but this 100 kg box will resist, because this big box, it's a heavy box, so it will resist. So we can say higher the resistance, greater is the inertia. Have you understood, children? If I am applying force, same amount of force on both, so this object will start moving, but this will resist the force. It will not want to change it wants to remain in its same state. Okay, so higher the resistance, greater is the inertia. Here what we are saying, because this is of less mass, this is of more mass, this is a heavier one, so we can say higher the mass, more is the inertia. So these are the two speciality of inertia. Higher the resistance, greater is the inertia. Higher the mass, or we can say greater the mass, more is the inertia. This has got less inertia, this has got more inertia. Now, after that we'll come to our previous topic. Here see, children. Here what we saw in this example, what we saw, the bigger box, the higher box will exhibit more resistance, okay, than the smaller one. The higher box will exhibit more resistance than the smaller one. The bigger box will not want to change its state of motion, because the mass is more and so resistance is also more. So in where there is higher mass or bigger resistance, we can say there is more inertia. Okay. Now, what is inertia of rest, what is inertia of direction, and inertia of motion? So already I gave you this example of a carpet example, like one dusty carpet is there. So how you will, what you will do, you just beat the carpet. So what will happen, the carpet will come in motion. Along with that, the dust particles which are at rest will fall down. So that is a very good example of inertia of rest. Now, inertia of direction. So for this, you already have asked you a question, you will get the answer in that only. When you are while traveling in a bus, when the bus negotiates to a sharp right turn, it will take a right turn. What will happen? You will bend to your left side, and when the bus will take to a left turn, you will bend to your right. Why it is happening? That is happening because of inertia of direction. What is inertia of motion? Can you give me one example of inertia of motion? We can get a very good example of inertia of motion from our day-to-day life. Okay. Let us look at a real life application in this inertia of motion. Okay, what happens in a car accident? If a person is driving a car and suddenly a car stops, in that case what happens? When the car is in motion, the body attains the same velocity of the car, and suddenly when it stops, the body will hit the vehicle, his body will be hit with the steering, and he will get so much of injury. Why is this happening? This is happening because of due to the inertia of motion. Okay. So it is very important for a person to wear a seat belt while driving. So these are the few examples of inertia of rest, inertia of direction, and inertia of motion. So in the beginning I asked few questions. I think you will be able to answer those questions about like what happens when you are traveling in a bus and you fall forward or backward when the bus starts suddenly and when it stops suddenly. So from here two conclusions we got about inertia. What are those? Due to inertia, first is the body remains in its present state. First is the body remains in its present state. Second, resist any change in its state of motion. The body remains in its state of motion. Present state of motion. Because of inertia, the body remains in its present state of motion. Second, it resists any change in its state of motion. So, children, today I have concluded this section. Thank you.